ናችሁ? ሰላም ናችሁ? This is from machine lecturing video, which is another lesson, which is a content which is extension of last lesson again. What I try to see under turbo machines, parameter involved under turbo machines, how to correlate the fluid parameter as the parameter of the devices. Therefore, there is a vane channel with that of correlation of vane channel with that of actual channel, and from last lesson I have seen how the plate, number of plate, again thickness of plate affect the deviation of actual flow from that of vane congruent flow. This is the another parameter or another factor which affects deviation of, or which influence the velocity, flow velocity of the turbo machines. Therefore, what's the effect of relative circulation? The second parameter, second factor. What's the effect of relative circulations? As you know, what does mean relative? It means that is what called inertiality. Due to performance of inertiality, or due to presence of inertial force, fluid velocity or direction of movement of fluid is in opposite direction to the impeller movement. Meaning that if we take the movement of fluid here, this one is the impeller. Then there is an impeller. This is an impeller. Again, you can also add another impeller here. We have seen what the difference between what the factor of increasing the number of blade channel or decreasing the number of blade channel, mainly in relating to the pressure distributions. Whenever you design the impeller externally high thickness, internally low thickness, that one is what we say sine sigma 1 and sigma 2 from our previous lesson or from my last video lecture. And whenever there is a sigma 1 thickness which is less than to sigma 2 thickness, this is from a continuity equations applications, which states that AB constant. AB is constant. What does mean that? Whenever there is high area, low velocity, and vice versa. Meaning that area 1, velocity 1 is equals to area 2 with that of velocity 2. Whenever there is a flow inside a channel. This is a channel flow. Two equations, as I said from my last video, two equations, two referencing point at point 1, then at the other referencing point 1. This is low height. If we take height 1, height 2 at the 2 position, if there is, for this position there is height, low height, but in this case there is high pressure. But in this case there is high height but low pressure. Then that's why bringing Cornell equation is very important in considering flow velocity in such way. Therefore, if you take the movement, what relative circulation. I am at relative circulations. Due to relative circulations, movement of impeller, the impeller movement, if you take the impeller movement from these directions, this is a movement of impeller is in opposing to circulation of fluid. This is a fluid velocity, a fluid movement direction is from in this way, but in this case it is from this way, therefore in opposite directions. Then what happened to the triangular velocity? What happened to the relative velocity? From the zero velocity, the at the exit side, the charging, the flow velocity of the tangential velocity decreased by the inertial amount. By the effect of inertial amount, the flow velocity decreased in magnitude. That's why if we take the flow velocity, triangular velocity at the exit side, this is at the exit side. Actually, this one is exit side one. If you take it, the original one is this one, but due to decrement of C2U decrement, C2U is decreased from its original position by this amount. There is a decrement in C2U. Why C2U decreased? Due to inertiality. But if you take at exit J, C1U is increased by this amount. That means decreasing from C1, let's say C2U by this amount, and adding it to the C1U by this amount. Why? Because of direction of flow is toward the C1U positions. That's why this one is in negative direction, this one is in positive direction. Therefore, if you take relative circulations, the influence of relative circulation is only at the exit J. No influence at the inlet J. At any inlet side, no influence present. If you take triangular velocity at the exit, that's why I wanted to, that's why I put here the triangular velocity configuration at the exit J only. This is the variation of the existed parameter at exit J. What are varied? First one, CTU is decreased in amount. Whenever CTU is decreased in amount, the relative circulation, the relative velocity also decreased. Why? Because this is the original one. Since this C2U is tangential velocity decreased by this amount, therefore this W2 is also actually the relative circulation is increased in magnitude. If you compare these two, this and this one at 1 and the 2, if you compare them in magnitude, the number 2 is greater than number 1. But what's the influence on it? The influence on it is there is a decrement in angle of inclinations. What angle of inclinations? Blade angle of inclinations. There is flow angle of inclination alpha, blade angle of inclination beta. Blade angle of inclination is beta. Therefore, beta angle is decreased, but which lead the increment in magnitude of the relative circulations, relative velocity, relative circulation around relative circulation. Therefore, what you have to understand on is what you have to remind is no, there is influence on alpha, which is flow angle. There is influence on beta, which is blade angle. Therefore, what happened to alpha? Decrement. What happened to beta? Decrement. But in case of the relative velocity increased in magnitude. What happened to the again the parameters that happen during designing turbo machines? Whenever you design turbo machines, they considering the material, considering parameter are first capacity. You have to take capacity, which is actually, you can also say that one as flow. Capacity means that, again, you have to take power. What power? Why? Because power is actually directly related with the capacity, flow related with flow rate. But it is the key determining factor of one devices. Again, you have to take into consideration what is the efficiency. Those three parameters are interrelated one. They are depending on one's dependent on the other. That means one is determinable by the other. Again, they are a key factor in deciding or in the designing mechanical device, especially turbo machines, whatever type of this, whether turbo machines or other type, very important one. Therefore, from our last lesson, Q, which is a capacity or flow rate in case of turbo machine, in case of fluid machines, which is determining by combining parameter pi into diameter. If it is at exit 1, diameter 1, again there is length beta 1 times the flow velocity. This one is must be flow velocity, meridian velocity. As you observe it, regardless of at exit, as you observe it, the influenced relative, the influenced velocity is C2U, which is Cu and Cw only. Why? Because C2U is the tangential velocity. That's why tangenting due to inertiality decrease the magnitude of that. Since C2U is decreased, there is an increment in relative circulation, relative relative velocity, but no influence on flow velocity. Same is a flow velocity, no influence on flow velocity. That's why if we take flow velocity here, no influence on flow velocity. Yeah, it's alpha. If we take flow velocity here, uh, yeah, if we take flow velocity here, this one is the original one. This one is the second one. If we take it, no, so much change in their variations from the original one. No variations, not so much varied from the original one. That's why no influence on flow velocity. That's why no, since the outlet is this one, they are not affected by relative circulations. Again, it is negligible at inlet side. Why it is negligible at inlet side? Again, due to the from what we have seen from my last lecture videos, at the first, whenever you design a designing situations, if you take the designing situations, yeah, a designing situation, if you take as this case, it is a narrow side. This case is a large side. Therefore, at narrow side, no influence on that. That's why it's stated. That's why the relative circulation is negligible at the relative circulation influence is negligible at the inlet of this channel on narrow side. The second, the other type of the other factor is effect of viscosity. What happened to the flow situations? with the viscosity of fluid. Fluid is either of gas or liquid. Therefore, mostly in case of liquid, it has its own viscosity nature. Therefore, due to this viscous nature, in case of flow, there is a formation of dead zone. As you observe from the screen, there is a formation of dead zone formations. Dead zone formations, mainly at outlet side of the channel. Again, no influence at inside channel. Why? Because relative circulation again no influence at the side. That's why you can also say that no influence at the inlet and outlet channel. No influence at the outlet channel. Due to formation of dead zone, again the nature of fluid or nature of flow influence it. There is an angle of the increment in angle of blade angle inclinations. The influence is mainly on the angle of inclinations. If you take this is a streamline, there is a blade formations. Blade formation here, the blade is forming here. I mean stagnant for the dead zone formations. And what happened to the overall to the configuration of the or to the parameter of the flow? What are the parameter of flow? Or whenever you have to memorize that there is a flow whenever we say the flow formations. In case of parameter, there is a velocity. Velocity is there. What type of velocity is there? Three type of velocity is there. That one is why it said triangularity formations. The first velocity is there is a flow velocity. That one is denoted as Cm. There is a tangential velocity. There is a relative velocity. Influential parameter, tangential velocity, relating to the flow velocity. Angle that formed due to flow velocity is alpha angle of inclinations. Angle that formed due to the blade angle. Blade angle meaning that the relative circulation formations is beta angle of inclinations. This is a difference. Therefore, parameter involved there from velocity there is angle of inclination of alpha, there is angle of inclination of beta, and there is three velocity formations. Three velocity formations. The CM, CU, CW is that of alpha and beta. The other type of parameters that involved is which is a combination of those parameters, mainly as I said earlier, capacity, there's a diameter actually, capacity, the other one is efficiency. Again, power, capacity, efficiency, and power. There is velocity, there is capacity, there is efficiency, and there is a power formations. Therefore, in this case, what is the influence of dead zone on the parameter? Increase of dead zone, there is an increase of dead zone with the free cross section plate channel is reduced. That means at the free cross section blade channel, where is the free cross section of blade channel reduced? At inlet side. At inlet side, there is decrement in size. That's why area of in area of dead zone, there is increment, there is a decrement in in area which is increasing in which lead to increment of the velocity. However, since there is no dead zone outside the channel, so we'll return to the case of no dead zone outside. Means that simply you can understand that one. If you take at this side, it's outside channel. If you take at this side, it is an inside channel. At the outside channel, this is outside channel. This is an inside channel. At the outside channel, the thickness is high. In case of high thickness, there is a dead zone. In case of low thickness, there is no dead zone. Simply. Then, what happened to the which factor influenced by the formation of dead zone? Angle of inclination. From as you observe from this one, there is angle of inclinations influencing. Again, there is the flow velocity as usual flow velocity increment. There is an increment in flow velocity, by this amount. This one is original, up to here original. This one is original one, but since at outside channel, since there is this one is not reduction, this increment, corrected increment. This is an increment side. Since there is an increase in angle of inclinations, blade angle inclinations, there is an increment in relative circulation and the flow velocity. In case of relative circulations, only flow velocity is increased. The relative circulation is increased, but there is a decrement in flow velocity, which is tangential velocity actually. But in this case, the two parameters are increased. What are the two parameters? One, increase due to dead zone, which is a flow velocity, or you can say that one as tangential velocity. Tangential velocity increased. Again, this one is irrelative circulations, irrelative velocity. Therefore, from this one there is an increment in magnitude. Relative velocity also increased. The other parameter is slip power, which is very important in fluid motion, as I said. There is a decrement in complexity of finding parameters there by applying slip power. Why? Because of steel, we have seen how the actual flow deviates from the concurrent flow. We have also seen how to calculate this at the inside to that of outside by simply having correction factor, having contraction factor actually, influencing factor. Again, we have also seen how to calculate beta node at the inlet side. But there is a difficulty in finding at B2 at the outside side. Therefore, to correlate CTU with that of C3U, there is a concept that developed slip power. There is a concept called slip power. This concept behind the slip power is to correlate these two parameters. Those two parameters. CTU, C3U. The only parameters that can correlate these two, those two parameters, CTU and C3U, are is called slip power. Mathematically, if you take slip power, what we have seen is this one is at the actual side, specific work done at the actual side, simply by combining the flow velocity at the inlet to that of the flow velocity within that of tangential velocity. Flow velocity with that of tangential velocity at inlet minus flow velocity with that of tangential velocity at outlet. At outlet mark inlet. Same is true at the case of vane channel. This is actually at actual 1. This one is actually at vane 1. Therefore, what sleep power state is that? Sleep power is the difference of the two, which is at infinite to that of the actual one. Infinite is inside of the vane channel, inside the vane. Actually, it is outside the channel. These are the actual situation. Mathematically substituting the systems, but the effect of definite number of blades at inlet is negligible. What is the negligible situation at inlet? One, radial circulation is negligible. Only there is a formation of dead zone, high dead zone formations. Again, the influence of viscosity is also negligible at inlet situations. Therefore, effect of definite number of blades at inlet is negligible. C1U to that of C02 is equal. Therefore, having a cancellation of V's, this one only left with Z2. But again, C through U is not known. Simply by finding C to U, the intention behind is finding C to U and C through U. This one is only possible if you have a sleep power, but it is impossible finding them analytically. Therefore, we have to develop the empirical equations. We have to find the empirical equations to get them in easy way. That's why the empirical formula development, which is developed by the two person philosophers, and again there is Stoddard's empirical formula. Those two empirical formula correlates reduce the complexity of finding C3U. Simply finding C3U is difficult. Therefore, the development of those two empirical formula decrease that complexity, decrease that equations. Simply, sleep power is the difference between at inlet to that of outlet, inlet to that of outlet. And simply by rearranging from these situations, y blade is equals to at infinity, simply by bringing this side actually. This y blade brings to this side, y blade infinity minus py blade, then simply rearrange for y blade infinity over 1 plus p. But p is the factor, y blade is at the actual side. Therefore, there is a C2U component there. C2U component, no, C3U component actually, but in case of infinity there is a C3U component. Therefore, our intention is to find C2U easily. P is called as sleep power factor according to philosophers, but it is a function of angle of inclinations with radius of the channel. There is an angle of inclinations, there is a radius of channel, there is a thickness, again there is a width combination. P is a function of those all parameters. The S is actually called the static moment of flow line. Static moment of flow line. Okay, is a factor dependent on flow guidance. Z is number of blade. Then S is simply area under the flow lines. It's an integrations. It is area under the secret behind integration is area under the situations. Therefore, from radius 1 to radius 2, that means area of from radius 1, that inlet to outlet side, and with that of simply integrating with the change of thickness, radius. Therefore, simply the static moment of flow line is a function of radius, but simply it is area under the flow conditions, area under the flow situations. The second type is Stodal's empirical formula. It's again empirical formula. This one is easier, simpler one, but not in good agreement with the real practical situations. Mathematically, what it look like is C3U, that means correlating C3U with that of C2U, as with a function of number of blade with angle of inclinations. Pi sine of angle of blade angles with that of the number of blade. Easy way from these situations, the number of blade is possible now getting them, but angle of inclination is again possible now. Then by having only C2U or either of C3U or C2U, possible finding one of them. That's why it is easy. Empirically it is easy. In this case, why simply there is a phenomena, there is another movement phenomena. Number of plate static moment with that of radius integrating is there. That means it is simply the situation that as it tend to more complex, it also close to the real practical situations. Getting complex, getting to reality. Let me see this example.